So I'm going to do 3 examples of the types of problems that we talked about on Friday. I could tell that not everybody was terribly competent. So let's go ahead and get started. So first move is that you have to actually get everything on one side of an equation, or an inequality I should say. So that's subtracting 50 from both sides. Okay? And then you solve however you know how. Alright, so you pretend that's an equation, solve it however you know how to solve it. So actually here you can divide both sides by 2 and get that. Now you never have to do something like that, but now we're going to deal with much easier numbers. And if you check it out, this is very factorable. This is difference of squares. Alright? So you may or may not remember that too well. I hope you remember it pretty well. But this is factors x plus 5, maybe, and x minus 5. Okay? And then what that means is, well, x plus 5 could be 0, x minus 5 could be 0. Remember, we're solving for, or pretending it's an equation. So if x plus 5 is 0, that means x would have to be negative 5. Okay? And then if x minus 5 equals 0, the opposite is true. It is equal to that. So either one of those possibilities, those are, I was calling those the magic numbers. Those are the ones that we will be able to use when we visualize the possible solutions here. Negative 5, positive 5. Now if this was a more complicated polynomial equation, you would have to check all 3 sections here, but really all you have to do is plug some number into here and see if it is actually greater than 0. Okay, why greater than 0? Because that's what we're checking for. That's what we're trying to solve. We just do this middle one, we'll know what the answer should be. Alright, so we plug, heck, let me change colors here. 0 is in between, you don't have to actually mark it in like I just did, but 0 is between negative 5 and 5, so heck, let's do that one. That should always pretty much work. In fact, you don't have to use the middle one. I was kind of being consistent because I felt like that was easier. But as soon as you really can plug into any one of these 3 regions, and you should know what the answer should be, and you'll see what I mean in a minute maybe. So you plug in a 0 into the x squared minus 25, or the 2x squared minus 50. It actually does not matter. It works out the same both ways. So I do, well, 0 squared minus 25. Okay, is that greater than 0? And the answer is correctamundo. It sure is. Oh, wait, no, it's not. What am I saying? It is not. Nope. Okay, that's a false statement. If you plug in a number in here, it is not true. Okay, it is not true that negative 25 is bigger than 0. So what you do is you're going to shade everything outside. If you want to draw it, I mean, when I say shade, change the shaded number line like in earlier classes. But really, ultimately, what I want is, I don't really care about that. I care about, can you write it in some sort of inequality notation. This is saying that x is less than negative 5. Okay, and remember, this is a greater than, so this has got to be the same. You do not have the or equals to anywhere in this problem. Or x could be greater than 5. Okay, and that should make some intuitive sense. X has to be bigger than 5 for this to work out, or less than negative 5, meaning if you square something bigger than 5, you're going to get something bigger than 25. You double it, it's bigger than 50. If you square something more negative than negative 5, it's like negative 6, negative 7, negative 8, you've got a similar deal. You square something, it's really big, and becomes positive, double it, and gets bigger than 50. Anyway, let's do a harder problem. Let's do this one. It's harder to factor. Alright, this is a problem that is more difficult to factor. Let's switch up the colors. Alright, so you're trying to factor out a GCF. You want to solve this. Solving by factoring will work. Alright, by the way, let me double back for a second. I could have solved this and it probably would have been quicker with the square root method, which is another thing that we did. Remember, when you do the square root method, you get x squared, equals 50. Remember, or 25. Okay. And then x equals plus or minus the square root of 25, which is 5. So I kind of did this the hard way, but partially just to remind you of factoring stuff. It was good for you. But square root method for this guy probably would have been a lot easier, actually. Alright. here. So solve this by factoring is what you got to do. So really this is AC method, so you got to brainstorm numbers that multiply to make A times C, so negative 36, and add to make negative 16. However you know how to, solve this. AC method, that's how I taught it a little bit last semester. Whatever you want to call it. Guess and check. Whatever. This works out to be 12 and 4. Nope, that doesn't work. Thought it did. Oh, wait, 18 and 2. So it could be like a negative 12 and 4 or something. It doesn't work out. Doesn't add up to 16, but 18 and 2 with the 18 being negative. That works out to be negative 16. There you go. I'm pretty good at this stuff. I've been doing it for a while, and my first guess was not right. All right, my first educated guess incorrect. So don't sweat it if it takes a couple tries. It happens to everybody. All right. So what that means is, if you're going to do this with the AC method, you've got to 3x squared minus 18x squared plus 2 minus x minus 12. And remember, we're pretending it's an equation. I'll just write equals 0. I know it's less than or equal to. We're pretending it's an equation temporarily. Okay, and so then we group these, and we think, all right, this is 3x with an x minus 6 and a 2 with an x minus 6 equals 0. So fully factored, we have an 3x plus 2 factor, and we have an x minus 6 factor. And heck, I'm going to kind of skip a step here. Remember, this factored equals 0. So what we end up doing, is we set both factors equal to 0. So I'm going to just cut to the chase here, partially for time reasons. So the factors are 3x plus 2 and x minus 6. Solve those both, and we get x equals negative 2/3, and 6. I guess I was thinking ahead to the 6. Okay, so negative 2/3 and 6, if I can actually get to write worth a darn here. Okay, so all these numbers, these are the magic numbers. These are the two numbers that we need to check between. So those are our magic numbers. Let me just make the number line with actual whoop with that. We have plenty of room. Okay. We have negative 2/3. And we have the 6. Okay. Doesn't really matter where you put them, other than the fact that they better be in the right order. And even then, not the end of the world, although it would be weird looking. But anyway, test the function, which let me bring back up. So once again, I mean, really, the vast majority of the time you just plug in 0. Okay. That's weird, it didn't copy as an exponent. Let me fix that, it'll look funny, I think, maybe if I don't. Alright, so we plug in 0, and we get, is this true or not? So we get 0 minus 0 minus 12 less than or equal to 0. Remember, we're checking to see if this is true. This is true. So we shade everything between the two spots here. In fact, I'll cheat a little bit and give this. Oh, wow, that's not what I wanted. A little thicker here, buddy. Boom. Oh, wow, that's huge. Boom. I want to emphasize the fact that it's shaded in circles. If you remember from our number line stuff from the beginning of the year and stuff from Algebra 1. Shaded in circles, so emphasizing the fact that it is or equals to is what you have to put in. And so this is negative 2/3 is less than or equal to x is less than or equal to 6. Alright? So, kind of crazy looking. I made that a little bit big, but you'll live. Alright, last but not least. Oh no, this is one that is actually not factorable. Okay? If you try to factor with the AC method, you're going to try to think of things that multiply to make 42 and add to make negative 16, and there's nothing that, no, it doesn't work. No nice integers that make that work out. So, so what you have to do is the quadratic formula. Okay? Oops. So let's do the quadratic formula here. So we have, actually, we'll break it down. We'll do the b squared minus 4ac part first. And so we get 256, that is 16 squared, negative 16 squared, minus 4 times 3 times 14. Okay, and so it's actually, I'll pause it and bust out the calculator. I forgot to get it. So here we go. Here's the discriminant about to calculate. 256, that's 16 squared, minus 4 times 3 times 14, so do all that, it's 88. So the discriminant is 88, which means we have two real solutions, but they are not perfect squares. Or excuse me, they are not rational, they're irrational solutions, so that's a heck of a thing. So what we get is x has to equal, remember the whole idea of pretending in this equation for a second, so we get the magic numbers that are the cutoffs for our answers. X equals, I never wrote the answer, what am I doing? 88. So x equals negative, well, nope, positive 16 plus or minus the square root of 88 all over 2 times 3 is 6. Okay? And so we go back to the calculator and we do that. So we get 88, I don't know why I typed that in again, 88 square rooted, there we go, forgot where that was. Let's just do the positive version, so it's 16 plus that, all over 6. So it's 4.2. So we go approximately 4.2 for one of the two solutions. And for some reason I lost the pen. Approximately 4.2. And here we do 88 square rooted, but that's going to be subtracted. So the way I'm doing this here on this guy, I got to negate it. This is the way that the calculator just said it. So make it opposite sign. So that's the minus the square root of 88 and 16. Okay, all divided by 6, and so we got 1.1. So the two solutions are approximately 1.1 and 4.2. Alright, so there we go. Okay, so there we go, there's our two answers. And so we're going to test in here in the middle, and then we actually don't have a great number here in the middle. So really we could just test 0. Alright, and it would, well, let's just do that. Let's test 0. Let's check out this. So notice the answers are always either between the two magic numbers or outside the two magic numbers. So if I plug in 0, which I have screwed up and went away from the pen, minus 0 plus 14 is less than 0. This is false, so we're going to shade in between, or I should say the answer is in between for time reasons. I'm going to do that because it did not work out here, so it means it must not work out in the other side, it must work in the middle. And so that means that 1.1 is less than or equal to x is less than or equal to 4.2. There you go. If you were to try a number in the middle here, if you plug in like 2 in here, you'd get something that would work out. But whatever. That'll work. Hopefully that was helpful. See you Monday.